Okay, so chapter 6, starting with 6.1, the very first thing it's going to have us do is, and this is where it's going to change gears just a little bit from the factoring sheet that we have. So everything in 6, 6.1, 6.2, 6.3, pretty much the whole chapter is all factoring when it gets down to it. The very first objective that they have you do is they're going to have you factor out a monomial. And on the factoring sheet, whether you've got the 2 terms or the 3 terms or the 4 terms on these things that we've got on here, the very first thing that you're always going to do is that anytime you do any kind of factoring, the very first thing you always want to look for is look for the greatest common factor. Which again is GCF. Okay, and here's where you have to bring the English lessons into the math class. You got to go for the noun part of it first. Hopefully I won't mess up my English skills. If you talk about greatest common factor, factor is your noun, and greatest and common, those are the adjectives that describe that one. So the big thing is that you have to find the factor. And remember, when you talk about factors, then the factors, that's the numbers that's smaller. So you want the biggest, smaller number, if you want to think about it that way. Okay, so very first thing that they're going to have you do when you go through these parts and kind of figure out what the numbers are here is they're going to ask you to, and this would be objective 1 that you're looking at. This would be the 6.1 objective. Where they ask you to factor out the monomial, that basically you're going to get something like this. You're going to have 25b squared minus 15b. Okay, and when we're talking about the greatest common factor and how you're going with this one, is that you're looking at the numbers. You're looking for, what's all the factors I can divide into 25? Well, there's only a couple of ways you can get 25. It's either 1 times 25 or it's 5 times 5. For 15, you've got 1 times 15 and 3 times 5. So you're looking for the biggest number that they have in common. Well, that's 5, right? I mean, you could go with a 1 for sure, but the biggest number you can get out of that's the 5. So when they ask you to take out the greatest common factor, it's going to be a 5. And as far as exponents go with the variables, the variable is basically is this. You're going to use the smallest power as a GCF. So the numbers, you just look at the numbers, and again, you take about how that you can factor this number and break it up in different ways. Everything you could possibly divide into it, and you're going to find out what the biggest number is. Variable-wise, you're going to use the smallest power that they have in common. Because basically on this one, you've got b squared and you've got b to the first. So if you talk about what the greatest common factor is for this one, it would just be 5b. Okay, now, and more than likely in the cases, they may ask you what's the greatest common factor, but at the same time, if they ask you just to factor it, because most directions it's going to say just factor. it's going to say factor out the the monomial, whatever you have to do. That once you figure out what the greatest common factor is, to actually factor this thing all the way out to be what it needs to be, you're going to basically do reverse distributor property. That, okay, we've got 25b squared and we've got 15b, that if we were to take those two numbers and divide them both by the 5b, what would be left over? So everything we were doing back in chapter 5, we were doing distributive property and the full method and all those different things. Factoring is just the reverse of that. Now we've got this expression that we multiplied out, and they're asking, okay, what would this thing look like before we had done either the full method or the distributive property? So they're kind of working this one out backwards. So if you've got 25 divided by 5, that would be 5. You've got b squared over b to the first. So again, you just take one of those out, that would just be the b. And then 15 divided by 5 would be 3. Okay, so this one, let's get that 5b down here. Okay, so they ask you to factor it. The factor expression would be 5b minus 3. Okay, if they ask you just for the greatest common factor, which they probably won't ask you to do in most of these cases, but if they did ask you for the greatest common factor, it would just be, again, 5b for that part. Okay, so if that was number 1, let's do a 1a here. Or that was 1a, if this is, make this 1b. And we'll just go through a couple of these just to make sure that we can get all the factoring out okay. Let's go with 14 a to the third plus 7 a squared. Okay, list off all the factors of 14. The only way you can get 14, it's either 1 times 14 or it's 2 times 7. If you do 7, there's only one way you can get 7, and that's 1 times 7. Okay, so number-wise, we've got the 7 that's in common. So if we look at just the greatest common factor, that's going to be a 7. And again, variable-wise, whatever the smallest exponent is, we've got a to the third, a to the second. So your greatest common factor would be 7a squared. Okay, and when you have to factor it, you're going to take whatever that greatest common factor is, put it on the outside, and then basically from there, make it a little more room here. Then you're just going to go back and take whatever this number is, 14a to the third plus 7a squared, and then divide it by your greatest common factor. Okay, so we'll put the GCF on the outside. And then once you've done the division, whatever you've got left over, that's the numbers you've got here. So 14 divided by 7 is 2. If you do 3 minus 2 on the exponents, that leaves you with a to the first, or just the a. And then 7 divided by 7 is 1. And in that case, you do have to put that 1 in there for a placeholder. Okay. And remember, if you've got a squared over a squared, that's going to cancel each other out. They'll knock each other out. And remember that you also could subtract it. So you get a to the 0, but again, anything to the 0 power is 1. Okay. All right, let's give you one more of those, just make sure we've got it here. Okay, so for this one, let's go 4m to the third minus 12m squared plus 160m. again, they'll tell you just to factor this one out. Now, and the key thing on this one is for everything that's here, they should tell you just to factor out the greatest common factor, factor out the monomial, so that you're factoring. The directions will be a little bit more elaborate for what we're doing. Okay, so over this one. Now, you've got three terms. Still going to do the same thing. It's 4, it's 12, and it's 160. With 4, you know, it's either 1 times 4 or it's 2 times 2. That's you know, you can't get any bigger off of the 4, so the numbers either have to be 2 or 4. If you go back and check it, you can divide all these by 4. So your greatest common factor would just be 4. And you've got M3, M2, m to the first. So you only take out the smallest power that you have, in that case m to the first, so your greatest common factor would be 4m. Okay, and then to get the numbers down here, we'll just take everything here and divide it all by 4m. So 4 divided by 4 is 1. That would be m squared. Doing 3 minus 1 on that one. 12 divided by 4 is 3. 2 minus 1 is the 1m that's here. And then 160 divided by 4 would be 40. Okay, so that's the first thing where, again, you're just taking out the greatest common factor. We're not really onto this sheet yet because this is where we're getting a little bit. But right now they're saying, all right, just that's the first, no matter what we do, whether you have 2 terms or 4 terms or 3 terms that they're going to ask us to factor in a little bit, you always look for a greatest common factor first. That if you can take that out, sometimes it makes the problem a little bit easier as you go through that one. So no matter how many terms you have, that's the first step you always want to do. See if there's anything they have in common, take that out, and then we're going to work with this part here to then get us to whatever else factoring that we need to do. Okay, second objective that they look at. Is a little bit different. They ask you to factor out a binomial from a polynomial. And this would be, if you're going through the list on here, that's objective number 2. And this one's just a little bit different the way they set it up. So this would be the first one to here. They're going to tell you to rewrite by factoring out x minus 2. And where they're really going with this one is they're kind of getting you ready for when we start doing some 4 terms, when we get to the sheet that we got here, when we start doing some 4 terms, there's some different things that we're going to do, and they're kind of walking us up to get ready for that one, plus a couple other things that we have to do. But that's kind of the first thing they're kind of getting us ready for here. And with this one, here's all that you're going to do. That they've given you this x minus 2 that we have here. They tell you you're going to factor this out. So basically, we've got the same thing here. And what they're really doing is they're saying, all right, just think back to, and kind of basics examples on this one. And you don't have to write this down, just kind of show you. But technically, if you had something like 4x plus 3x, we put the x's in parentheses, technically you're supposed to take the 4 and the 3 and add those together, and whatever this x is that's back here, you would just put it behind it, and then you do 4 plus 3, and then you get 7 with the x. Okay, that's technically what we're supposed to do, but we don't do it that way because it's a lot easier just to go, well, if I've got 4 x's and 3 x's, I put them together, I've got 7 x's. Okay, and that's okay, but once they make the variable a little bit longer, they kind of come back to this when they say, well, as long as these two things are the same with the x minus 2, we can take whatever numbers or coefficients we have in front, and we can add or subtract those two things together. And then the x minus 2 is just going to kind of fall in. Okay, now, and if you can add these numbers together, go ahead. But if you've got 7x squared minus 5, they're not like terms. So for that one, that's as far as you can go. So that's all you can do with that answer. That's all you can do with that question. And it seems like you could do more with it, but for this one, again, they're kind of getting you ready for the next objective that's coming up. So for this part of it, they're really not going to do just a whole lot with this one because it's just a couple little easy little steps to kind of go through this one. The only other thing they might have you do same step, same type thing here, just to give you something different to look at. It may be that you get 4y to the third times y plus 6, and then plus 10 times y plus 6. And again, they would tell you to rewrite by factoring out y plus 6. And same concept here, that you've got this y plus 6 that's the common part. So we'll just kind of put it at the end. And whatever numbers you have in front, put those in parentheses together. And then, again, if you can combine like terms, you can. If that had been just, 4 here, then you could do 4 plus 10. You could make that 14, and then have the y plus 6. But because they give you that with the variable, it's going to stay there because you're not able to add the 4y to the third plus 10. It's just going to stay that way. Okay, so small little step on that one. And again, they're really, it's one of those little, I would say that's almost like a review objective because they're kind of saying, all right, here's something that you're going to do. Here's the big thing they're kind of looking at for you to do with a 6.1. This is where we've got objective 3 here. They're going to tell you to factor by grouping. Okay, so now we're actually back to this handout that we had on Tuesday. Factor by grouping. If you notice on this one, this is one that's got 4 terms on it, that if you have 4 terms, you're always going to do factor by grouping. Okay, and it tells you, first step is you always look for a greatest common factor, which you're probably not going to have in this case. They might sneak one in on you, but more than likely, probably not. And we've got the 6 steps to kind of do with this one, that if you have a problem, let's go ahead and give you one here. So let's say that's our first example we'll look at. W to the third plus 2w squared plus 7w plus 14. And again, if it's 4 terms, if it's factored by grouping, you have to have 4 terms. Okay, and as long as the terms are in descending order, you can pretty much always do the exact same thing. So if they're not in descending order, you probably want to turn around and get them that way. You should be given, every problem I looked at, they were given in descending order. So we should be fine when we go through this one. But you're going to group the first 2 terms together. And I always tell people, regardless of what this sign in the middle is, I'd always go back and put a plus. And then you group your last 2 terms together. So, and we'll look at one in a minute where that's a negative, and we'll give you a little different look to it. So there's your first step. Just, again, break it up in 2 parts. First 2 terms together, last two terms together. And then what you're going to do is you're going to take the GCF of both of the two different pairs you have. So for this part, you've got 1 and 2. Well, if it's 1 and 2, then you know 1's going to be the only number you have. You've got W the third, W the second. So for this one, you could take out a W squared as your GCF. Okay, if you take 2 of the W's out, you've got 1 left over. If you take these 2 out, you're left with just the 2. And the second set, 7 and 14, you can divide them both by 7. So divide out the 7, that'll leave you with a W with this one. Take 14 divided by 7, that'll leave you with a 2. Okay, and on the sheet, basically that's the first 4 steps that we have there. We grouped the first 2 terms together, grouped the last 2 terms together, took the greatest common factor out of each of them. And step 5 is not even really a step, it's more like a checkpoint. As long as you've done factor by grouping the correct way, this has to be the same as that. If it's not the same, you did it wrong. They have to be. Those 2 parentheses have to be the same. And if they're not, then you did it wrong. You got to go back and check your numbers. I mean, there's no other way around it. That's the only way factor by grouping works. And then once you've got these 2 parentheses the same, well, now it's like the objective that we had back up here, that if these 2 things are the same, you just take whatever the numbers were in front, and you're just going to add those 2 parts together. So we'll take the W squared and the 7, and then we'll add those 2 things together. And then that would be your final answer. And really what the 4 terms is, it's when we did the full method, you know how we did the F and the O and the I and the L, going out doing that part. This is, here's your F, here's your O, here's your I, here's your L, that if you went back and did the full method on this thing, you would get back to this answer. So all that factoring is just reverse distributive property. Okay, let's give you one with a few different signs on it just so we can see what it looks like. Okay, let's go u to the third plus 5u squared minus 5u minus 25. And if you want to back here, you can actually go ahead and put this as objectives 3 and 4, because objective 3 is factor by grouping, objective 4 is factor by grouping. They just changed up the problems, which means one of them they changed up the signs a little bit. So it's the exact same problem, one of them they just changed the signs. So it's really not any different when we go through the parts on this. Okay, so same thing, we'll go here. And again, if you put a plus in the middle every single time, no matter what the problem is, that way when you do this one, that negative has to go with the 5. The one before it, if the sign happened to have been positive like this one was, that's okay. If you double up on the positive signs, that's fine. But whatever this sign is, it always has to go on the inside with this number, and I always put a plus there regardless, just so that the signs match up as you go through these. Okay, u to the third and 5u squared. U squared is about all you can take out. That'll leave you with 1u here. You take out the u squared, that'll leave you with a 5 here. With negative 5u and a negative 25, they're both negative. So when you take that part out, it is going to be a negative. 5 and 25, you can divide them both by 5. That'll leave you with a positive u. If you do a negative divided by a negative, makes that a positive 5. And again, there's your check, because now you've got the same thing in both parentheses. As long as those are the same, your math is good. And you can just take these 2 numbers and pull them together into one parentheses. Okay, and the closest thing to a trick question on these Again, this may be in objective 3. It's all still in that same area. Again, it's just the only difference is some of them they use a little different signs. But this, I think this would be more of an objective 4 type question. But it still fits in the same thing. The only thing I can think of that might be the closest thing to a trick question would be something like this. So we'll group the first two terms together. And then group the last two terms together. Okay, so you've got negative 20, negative 35. They're both negative, so we know we're going to divide them both by a negative. They both end in zeros and 5, so for that part, you would basically factor out a negative 5. Now, you do have x to the third and x to the second, so again, you take out the smaller amount of exponents, so make it x squared. Negative divided by negative is a positive. Negative divided by negative is a positive, and that's 7. And then when you get to this one, you go, well, there's really nothing I can take out of 4x plus 7. So here's the trick on this one. Because when you get here, you may go, well, I've already got the same thing in this parentheses and this parentheses, but I didn't take a number out. If this one doesn't change, if this is already the same, there's nothing you can take out, just take out a 1. So if you do get two numbers that if you look at it and you go, well, there's nothing here that I can take out, just take out a 1 so that now this does match with this, and then you can do the 5x squared plus the 1. Okay, that's the only thing I can think. That's about the only way you can get a trick question on this one. Other than that, it always works out how it should. And again, if you get here and these two things are different, you did something wrong. If it's already if you take this one out and you go, well, that's already the number I have here, then you just take out the 1 because you can take 4 and divide it by 1. You can take 7 and divide it by 1, and you're basically almost using that 1 almost like a placeholder out front there.